Hey everybody, Chad here again, and today we're going to talk about deployments in Kubernetes. One of the benefits to Kubernetes is this built-in high availability, so ensuring that your application running inside of Kubernetes is always available. And to ensure this 100% uptime, we create what's called replicas, and these replicas exist inside of a replica set. And in the case of a stateless application, this replica is just another iteration of your application. And usually it's put behind something like a load balancer, which in Kubernetes it's called a service, and is able to distribute that load to those replicas. So if we take a look at our diagram here, you'll see all the way on the left-hand side, we have this deployment. This deployment resource in Kubernetes allows us to declare what application is running. In this case, it's the Nginx image, but also how many replicas there are. In this case, 5. So this deployment YAML that we're looking at on the left-hand side here is the specifications for our app. How do we want our app to run? And so in Kubernetes, we have this way of describing how we want our application to run. And then the deployment makes sure that it runs that way all the time. This is called a declarative nature of running our applications. When you create this deployment, it also creates a replica set kind of behind the scenes. And this is a completely different resource in Kubernetes. So this replica set ensures that those 5 replicas are always running at all times. And this gives you a couple of things. This gives you the ability to kill pods within that deployment and those pods automatically being spun back up. And it also gives you the ability to revert to a previous replica set. So each time you change, let's say you change the image in the deployment, or you change other characteristics within that deployment, you have the ability to revert back to a previous replica set. And in Kubernetes, we call this a rollout. So let's say you're going from version 1 to version 2 of your application. In order to do that in Kubernetes, you would perform a rollout, and you're rolling out a new iteration of that same deployment. Another aspect of the high availability is the ability to stack your control plane components. So if we see on the right-hand side of our diagram, we have the control plane node behind a load balancer. And this gives you the ability to elect a leader to say all incoming requests are going to this control plane node, this API node. But in the event of a failure, it could always elect a new leader and have the second or third API take over in its place. And same goes for the etcd cluster. A lot of times we refer to this as a raft when etcd is stacked like this, so that, again, it's a leader election process that takes place so that you're only reading and writing to one etcd copy or instance, and then all of those others are just reading from that leader and able to replicate that data, so that if you lose one of those instances in the raft, the other members are able to take its place. So if we go over to our Killer Coda website and we open up a terminal, if you want to follow along, you can go to killercoda.com/playgrounds/scenario/Kubernetes. And creating a deployment is as easy as this. So it's kubectl, or K for short, create, deploy. Let's name our deployment Nginx and give it the image Nginx. So now if we do kubectl git deploy, we'll see we have one deployment. And within that deployment, we have a replica set, as we mentioned before. So we'll do kget rs, which is short for replica set. And then, of course, we have the pods, which are actually running the application, in this case, the Nginx application. So kget pods lists the pods in that deployment. And we didn't specify a replica here, so by default, it assumes that we mean one replica, meaning one pod within that deployment. If we wanted to change the number of pods that are in that deployment, we could perform a scaling operation. So to do that, we just do kubectl scale deploy Nginx and give it a number of replicas. Let's say we want 5 replicas, just like in our diagram. So now we see if we do kget pods, we see that there are now 5 pods in that deployment. If we do kget rs again, we'll see it's the same replica set. It did not trigger a new version, but let's go ahead and trigger a new version now. So let's do the command kubectl set image deploy nginx, which was the name of our deployment, and then nginx, which is the tag for the deployment. We're going to change that to nginx with an image tag of 1.14.2. And then we can even add a verbose output, and just to give us more output in the terminal so we can know what's going on. And we'll do 6 lines. So that triggered a new replica set. If we do kubectl get replica sets again, we'll see there's a second replica set. And if we do kget pods, we'll see there's a new set of pods. And as I said before, when you create a new version of the application, this is called a rollout in Kubernetes. And in order to view our rollout history, we can do kubectl rollout history, deploy, and then our deployment name was nginx again. So as we see, we have 2 revisions. Revision 1, which was the state of our deployment when we initially created it. And then revision 2 is the version of our deployment when we changed the image. So let's say we wanted to roll back to revision 1 of our rollout. We could do kubectl rollout undo, deploy nginx, and then we can choose the revision that we want to revert to. So we'll do to revision 1. So we could see if that was successful by doing kubectl rollout status, deploy nginx, and it was successfully rolled out, or in this case, rolled back. And then we could do rollout history again. And we see now we have revision 2 and revision 3. We rolled back to revision 1, and therefore it became revision number 3.